So question 2. Which compound matches the IR spectrum? And then they have different compounds from A to F. So basically with IR, each of these different peaks corresponds to certain functional groups in the compound. So I looked up the different IR absorptions of common functional groups in advance, and this is kind of the example of the different locations of all of these different functional groups. So first I'm just going to look at our spectra. We have peaks at around 2,690 inverse centimeters to around like 2,700 inverse centimeters. So let's look at our IR spectra, and you'll see that this corresponds to alkane groups. And in particular, it's not in that table, but basically it's for sp2 CH stretches. You'll also see a characteristic peak at around like 1,700 inverse centimeters. And then let's look at our table. So basically this is due to like carbonyl groups. I'm gonna write So let's look at all our different options. So let's look at A. There are 2 double bonds. So if we look at the absorptions you expect to see for alkenes, you'll see it's in around like the 1,600 range and also the 3,000 range. And then you can see that that isn't present in our spectra. So let me just write down. So there are no 1,600 peaks for double bonds. So we know that it's not A. So let's look at B. So for aromatic groups, there are peaks at around 1,650 to 2,000. So let's look at our spectra. There are also no peaks whatsoever for these locations. So already, not only can we rule out B, we can also rule out F, since they both have aromatic rings. So looking at C, you'll see that there are alkanes, and they also have sp2 hybridized carbon hydrogen stretch, which is what we're looking for, and it also has the characteristic carboxyl peak at 1700. So it could be C, but I'm still going to go over all the different molecules. So with a compound like D, there should be overtone carboxyl groups, but it's not there in the spectra. So we can rule out D. E has an NH group. So let's look at the peak we expect for NH. So you expect to see it at 3,300 to around 3,350 inverse centimeters. So let's look, and you'll see that there is no peak present. So therefore, it is not E as well. Yep, so the compound is C. So let's look at the answer. Peak at 1730 indicates the presence of carbonyl stretch. The peak at 2,976 inverse centimeters indicates the presence of alkyl stretch. They also have the peaks at around 2,800 and 2,700 indicates the presence of CH stretching in the aldehyde group. Therefore, the possible compound which matches the IR spectra is butanal. The structure is as follows. Okay, so we are right, and the solution is correct.